You used less electricity last month than the month before, and your bill still went up. If this has happened to you, demand charges are almost certainly why. Today, we're decoding demand charges, what they are, how they're calculated, and what you can actually do about them. I am Daniel Burke, and this is Energy Answers brought to you by Tactical Energy. If your electric bill runs five figures or more every month, this episode is absolutely for you. And here is the short version before we go any deeper. A demand charge is a separate line item on your utility bill based not on how much electricity you use, but on the fastest rate at which you drew power during the billing period, measured in kilowatts, not kilowatt hours. For large commercial and industrial customers, demand charges commonly exceed 50% of the total bill. That means one peak reading can drive the majority of what you pay. The question for your operation is whether you understand where that number comes from and whether you have any plan to actually control it. Before we go further, if you've already watched episode 11 on peak shaving, you know the strategies. Today, we're pulling back the curtain on what you're actually fighting against. And if you caught episode 14 on battery energy storage systems, once you understand demand charges at the level we're going to cover today, you'll see exactly why battery storage pencils out the way it does. Now, let's get into it. So, what is actually on your utility bill? It's three things: fixed charges, they're unavoidable, assessed for being connected to the grid; energy charges billed per kilowatt hour based on total consumption over the month; and demand charges billed per kW based on the maximum rate at which you drew power at any single point during that billing period. Most operators understand this energy charge intuitively. You use more, you pay more. Demand charges do not work that way, and that is where the confusion lives. So here's the distinction: energy measures total consumption over time, kilowatt hours. Demand measures the rate of consumption at a given moment, kilowatts. Think about a central air conditioner rated at 3,500 watts running for 8 hours. That draws 28 kilowatt hours of energy. Now, add a 4,000 watt water heater at the same exact time for those same exact hours. Your combined demand at that moment is 7.5 kW. Run the water heater before the AC kicks on instead, and your demand never exceeds 3.5 kW. Same total energy consumed, kWh, completely different demand reading and a different all in bill. The gap between what I used and what I'm actually billed for is where the demand charge actually lives. Now, most utilities measure demand on a 15-minute interval, though some use 5, 30, or 60-minute windows. Check your tariff. Your tariff is the rule of the game. Whatever the interval, the highest average draw in any one of those windows becomes your billing demand for that entire month. One bad interval, even on one day, can define your costs for a full 30 days. Now, what types of demand charge structures are you likely to see? There are five. Max or non-coincident demand is charged based on your highest draw at any point in the billing period, regardless of when the utility's system peak occurs. Time of use demand is charged based on your highest draw within a specific defined window. On peak periods, which vary by utility. Flat demand applies a single rate per kilowatt to one demand reading. Tiered demand applies different rates depending on whether your demand is above or below a threshold, and daily demand charges are billed per kilowatt per day across the billing period, a newer structure that's expected to become much more common. Now, the one that catches operators off guard: ratchets. A demand ratchet is a minimum billing floor. Your actual demand in a given month might be far lower than what you're actually billed for. The most common ratchet types are fixed kilowatt minimum and minimum delivered from applying a percentage to a referenced demand from a prior period. And here is a real example: a utility tariff that sets a fixed minimum billing demand of 100 kW during winter months says your billing demand cannot be less than 70% of your highest metered demand from the prior summer. If your peak in August was 400 kW, your November billing demand is 280, no matter what you actually drew in November. A single summer startup event or equipment test can set your billing baseline for months. Audit your tariff for ratchet language. This is not a hypothetical. This connection is also why episode 9 on utility bill audits is worth revisiting. Demand charges are one of the most common places billing errors and misapplications actually hide. On mitigation, the most accessible near-term lever is load sequencing. Do not run your largest loads simultaneously. Stagger startups. Schedule discretionary loads outside on-peak windows where your tariff defines them. These are operational decisions, not necessarily capital investments. For facilities with the right load profile, battery energy storage for peak shaving can produce real paybacks. A vendor case study from Sunlith Energy describes a manufacturing facility with $50,000 plus per month in demand charges that installed a 5 megawatt, 10 megawatt hour system and reported a 35% demand reduction with a 4-year payback. Treat vendor case studies as directional. The economics depend heavily on incentives, tariff structure, and whether the battery is also earning ancillary revenue. Check the episode we did on FERC Order 2222 if you want to understand that a bit better. One more thing worth knowing: solar does not reduce demand charges as efficiently as it reduces energy charges. Solar generation doesn't reliably coincide with your peak demand window, especially under time of use tariffs, where on-peak periods run into the evening after solar output drops. And intermittency from passing clouds can create demand peaks rather than shave them. That's why solar alone rarely moves the demand charge needle the way it moves the energy or kWh charge line. If a vendor is pitching solar as your demand charge solution, push back on that math. So here's what I want you to take from this. Demand charges are not a line item you negotiate away. They are a structural reality for you. They're in your tariff, and if you do not understand exactly how they're calculated, specifically the interval measurement window and any ratchet provisions tied to seasonal peaks, you're making capital decisions, operational decisions, and budget forecasts without the information you actually need. Demand charges commonly run more than 50% of a commercial and industrial bill, and that's not a rounding error. That is the majority of what you pay, and the trend among some utilities is toward more demand charge complexity. California utilities pushing more cost recovery into time of use demand. PG&E's option S introducing daily demand charges, and APS and Duke offering residential demand rates. It is uneven and contested at the regulatory level, but the direction is worth tracking in your service territory. Now, obviously, I don't run your facility. That's your job. My job is to bring you definitive answers to the most pressing energy questions facing commercial and industrial operators like you. So the bottom line on demand charges: reducing kilowatt hour consumption alone will not fix your bill if demand charges are driving the majority of your cost. The number that matters is your interval peak, and a ratchet provision in your tariff can make a single bad day expensive for months afterward. So here are a few questions worth bringing to your team. Do you know what percentage of your electric bill is demand charges versus energy charges? And have you pulled that number in the last 90 days? Does your tariff include a ratchet? And if so, do you know what your current billing demand floor is based on your prior seasonal peaks? Are your largest equipment loads staggering at startup, or are they coming on simultaneously and creating a demand peak you could avoid with a scheduling sequence? And if someone has quoted you a solar or storage project recently, did the financial model account for your specific demand charge, structure, and rate? Or did it model generic regional assumptions? Hey, if today's episode got you thinking about a project you have in the works, whether that's storage, rate analysis, or just getting clear on what your bill is actually telling you, I want to help. Me and the team at Tactical Energy Group created the Energy Decision Blueprint for Indiana-based commercial and industrial operations spending 5 figures or more on electricity each month. And here's how it works. We'll get on a short call with your team and learn about your situation to figure out if we can actually be helpful to you. If I can't, I'll tell you as quickly as possible and I'll give you your time back. But if I can, we're going to move to data, bills, interval data, and quotes or pro formas you have on the table. Then we'll take all of that back to the team and crunch it and give you a full opinion. whether the project makes sense for your specific operation, whether the payback will actually materialize, and whether there are actually opportunities or risks that the vendor has not surfaced for you. You'll get all that in writing on a follow-up call with no obligation to anything else whatsoever. And it's free to qualified Indiana operators. So click the link in the description below or go to tacticalenergygroup.com and look for Energy Decision Blueprint. Thank you for listening to Energy Answers by Tactical Energy Group. If this helped, send it to another operator you know who's dealing with the same headaches, and visit tacticalenergygroup.com to get more practical tools for your facilities.